Welcome everyone to our webinar on fall protection basics. This is our second episode in our fall protection series. My name is Matt Burtney. I'm the content marketer for Levitt-Safety, and I'll be your moderator for today. And joining me today is Jennifer Abraham. She's the training manager for Honeywell Canada. She's worked with Honeywell for over a decade and previously worked as an HSC coordinator and site training manager in the oil and gas industry. So thank you, Jennifer, for making the time today. I look forward to the interesting conversation, and I'll pass the microphone over to you, and I'll be back near the end.
Great. Thanks, Matt. And thanks everybody for joining us for webinar number 2. So today we're going to talk about fall protection basics. And really happy to be back again with my friend Matt from Levitt-Safety. So in this webinar, we're going to talk about how long it takes to fall, types of falls, same level falls, slips and trips, stairs and ladders, types of ladders, falls to a lower level, and best practices to avoid falls from those locations. So how long does it take to fall? We've got a little chart here, and in a few modules, you're going to hear us, you're going to see this chart again, and we're actually going to add some speed. So how fast that you're actually going when you fall these distances. So many workers believe that they have enough time to react and catch themselves. So a lot of people think they're going to reach their hands out and they're going to grab something and stop themselves from falling. That's simply not the case. We've actually fallen several feet before our brain even kicks in and goes, oh crap, I'm falling. So just a couple of examples on the chart. 1 second, you've already fallen 16 feet. 1 second, that's not a long time. 2 seconds, 64 feet, 3 seconds, 144 feet, 4 seconds. Only 4 seconds, 256 feet in 4 seconds. So we're gonna talk about in a few modules from now, a few webinars from now, we're gonna talk about how fast that you're actually going when that occurs. So injuries most commonly associated with the fall include broken bones, sprained ankles or wrists, knee damage, shoulder dislocations or muscle strains, spine and nerve damage, traumatic brain injury, cuts and bruises. So Matt, in your opinion, what do you think takes longer to heal, a cut or a sprain or a tear?
I'm going to say a tear.
Yeah, for sure. Sometimes when we break something, we break it, it gets put in a cast, it gets set, 6 weeks later, we're out of the cast and hopefully we're good and rolling again. But things like muscle sprains, strains, and dislocations and things like that, they can cause some serious incidents and injuries. So the incident I talked about for myself in the very first webinar was a knee injury that I had sustained doing a bunch of things a safety person probably shouldn't do. So in that, I had a lot of injuries in my leg, but it was all strains and sprains and nothing was even actually torn, which was shocking. But over time, there was actually a lot of muscle memory. So your muscles start to learn how to work differently to help you cope with your injuries. And then when those things are repaired or you try and get them back to normal, all of the muscles and ligaments and joints and everything just hurts because it's not working the way that it should. So it takes a really long time to repair ourselves from muscle sprains and strains and tears. So, and the older we get, again, the longer it takes. Spine and nerve damage. Yeah, we talked about traumatic brain injuries, and we're going to talk more about some of these things. And we also went over some incident reviews and things like that in the first webinar that kind of outlined some injuries and things like that as well. So when we think about falls, we usually think about falling from a height. However, that's not the only fall that we need to prevent. We also need to consider same level falls, stairs and ladders, and falls to a lower level above or below grade as well. So we're going to individually talk about all of those things. So same level falls, according to the CCOH&S, stats show the majority of falls, 67% of falls happen on the same level, resulting from slips and trips. A lot of times on our start cards, our FLRA, our JHA, whatever we're calling them, Everybody writes down slips, trips, and falls, slips, trips, and falls, but they never write down what are we all slip, tripping, and falling on. So how are we actually controlling those things? It's one thing to be aware of the fact that we may slip, trip, and fall, but the main game is to try and eliminate the opportunity to do those things. And I always say opportunity, and that sounds like it's a good thing, but it's not really. I just want to make it sound not as bad. But in falls, it can be bad, even on the same level. So the remaining 30% of falls are from a height. And I would imagine there's another, so for you math whizzes, then there's another 3%. That's a miscellaneous that they decided not to include. I always get somebody in my class that says that doesn't make 100%. So slips and trips. Slips happen where there's little to no friction or traction between the footwear and the walking surface. So common causes of slips would include wet or oily surfaces, occasional spills, weather hazards, loose, unanchored rugs or mats, flooring or other walking surfaces that do not have the same degree of traction in all areas. When I worked at one of the very large refineries in the Wood Buffalo area in Fort McMurray, there was a site there that I had worked on, and in order to keep the dust down, they would actually take one of their trucks around, and they would spray this oily water mixture around on the dirt. And instead of just spraying water to keep the dust down on site, because it would dry too quickly, and then the same problem was there all over again. So they put this oily mixture, which didn't dry obviously as quickly and kept the dust and stuff down. However, you would walk on it, and this oily bit of substance would get on your boots, and then you go to try and climb a ladder, and now you've got this oily substance that's now on the rungs of the ladder that your hands are also touching as well as other people. So it was a great solution for one problem, but it created another potential slip from a ladder hazard instead. And obviously having a bit of oil on your boots and then going inside to a building on a linoleum floor or something like that, the oily surface on your boots is going to create some slip hazards. Trips happen when your foot collides or strikes or hits an object, causing you to lose balance and fall. Common causes of tripping would include an obstructed view, poor lighting, clutter in your way, wrinkled carpeting, uncovered cables, bottom drawers not being closed, uneven steps or thresholds in walking surfaces. I've seen a variety of different things. I've seen a concrete step at the bottom of some stairs. It was engineered. The guys poured the concrete exactly where they were told to. However, the step actually, the stairs themselves, on the last concrete step that was poured, the metal steps came down, the graded steps came down to the last concrete step, and the stairs actually were right in the middle of that step. So by the time you went to step down, only your heel just barely was stepping on, could step on that, and the rest of your foot was already rolling off. So there was some engineering problems. So just because I'm sorry if there's any engineers watching and you're sensitive, sometimes we have the best intentions, but they don't always pan out the way that we had planned. So it was a little bit of poor engineering, some measuring. Nobody really took notice before and stopped and took a step back and realized that there was going to be a problem. So how to prevent falls due to slips and trips. So slips and trips result from some kind of unintended or unexpected change in the contact between the feet and the ground or walking surface. The fact shows that good housekeeping, quality of walking surfaces or flooring, selection of proper footwear, and appropriate pace of walking are critical for preventing fall incidents. So we can't wear the same type of footwear all year round. Excuse me, maybe if you live in British Columbia, you can, and it just rains in some places in BC on the island. But if you live in Alberta, I certainly can't wear the same type of footwear all year round. So, I live on a farm. I've got a nice set of boots that are like an overshoe boot that have got some cleats in the bottom. They're actually wonderful and magical. On every job site these days where I've been to, they've got some type of slip resistant type of, devices that you can just attach right to your shoes, right to your boots. You don't have to worry about having a specific type of shoe or boot, and the employer is typically providing those things in many cases. So your work area. So wear appropriate slip resistant shoes. So obviously having footwear that's in good condition is a huge thing. You know, there's some parts of a situation we can't control, but our footwear is certainly something that we can control ourselves. Slow down to negotiate turns and corners and obstacles in areas of limited visibility. Keep your workspace and walkways clean and clear and well lit for you and your visitors. So do not allow electrical cords or other objects to extend across a walkway. You know, if you absolutely have to, there's ways to cover those cords up, provide some type of flagging or some notification to look out for those things. Tie up any cords that might pose a trip hazard and tape down or secure cords temporarily located in traffic areas. So just a couple of tips, you know, to keep your work area clean and obviously to prevent trips. Flooring. So changing or modifying the walking or working surface is the next level of preventing slips and trips. So like I said, sometimes there's only certain things we can prevent or we have control over, and that would be our footwear. So the next would be, you know, hopefully our employer or the site we're working at making some changes to the actual walking or working surface. So recoating or replacing floors, installing mats, pressure sensitive abrasive strips or abrasive filled coat on paintings. So there's lots of paint that there's some grit and some type of traction associated with it. You can also have some type of synthetic or metal decking. Obviously, all types of decking, flooring requires good repair and good housekeeping. Doesn't matter what kind it is. Stay alert for uneven surfaces. Watch for curbs and potholes when moving between vehicles. Assume there is ice if the temperature is close to freezing. Slow down and take short strides. So at one of the refineries, they actually have a big penguin that they blow up every winter. And they tell everyone to walk like a penguin. So, you know, when we take our feet and we kind of change the trajectory of our feet there's less opportunity for us to slip when our feet are like so, as opposed to our feet being like this. Oh my gosh, it's almost like I talked about this already. So footwear, it talks specifically in the first line about the floors may be oily or wet. So I just talked about having an oily surface and that sticking to our shoes. So in workplaces where floors may be oily or wet or where workers spend considerable time outdoors, prevention of fall incidents should focus on selecting the proper footwear. Since there is no footwear with anti-slip properties for every condition, consult the manufacturer is highly recommended. So like I said, you know, there's many different lines of footwear out there, and not one of them is probably going to suit your needs 12 months of the year. Having been out in the field, I realized that this is a reality that some people are like, yeah, man, I'm wearing the same pair of boots all year round. I used to do the same thing until I came to Honeywell, and I realized that there are so many different products that were so easily available to me, no matter what manufacturer that it is. Sometimes we only know what we know. And when our employer is the one that's typically responsible for providing us with our PPE, sometimes when some of the choices like footwear are left up to us, again, we only know what we know. So, you know, do your research, ask some questions to your safety people as well. And maybe there's something that's going to work out better for you. It's, you know, it's just like in Alberta, just because you have all season tires doesn't mean that you're allowed to use them all year long. They're not really all season tires. You still need winter tires. So it's kind of the same thing, right? So stairs and ladders. So stairs are most commonly used, but they do have their own contributing factors when it comes to falls. So people neglecting to use the handrail. So many times I've seen, oh, it's coffee break. Guys put their hands on the handrail, feet up, and they're going straight down to the bottom. They want to get down to coffee break as quick as possible. So obviously, you know, not using ladders and handrails, stairs and handrails and things like that properly could be contributing factors. Other factors could be poor design. I already kind of called out one of those things. Housekeeping, poor maintenance, inattention, unsafe behavior. I just mentioned that, and inappropriate footwear. So stair surface, to reduce the risk of slipping on stairs and non-slippery surfaces on the whole step, or at least the edge of the step, is crucial. Such a surface can be made of rubber, metal, or painted with special slip-resistant paint. Regular maintenance of the stairs and kept in good repair is a plus for sure. And good housekeeping can reduce tripping hazards. So encourage the use of handrails. So, the handrail's not going to stop you from falling altogether, but it's going to stop you from falling down to the bottom of the stairs. The hope and desire is that if you fall and, you're headed down the stairs, you're going to end up turning yourself in towards the handrail. So, and, maybe you're only falling a couple of stairs, still holding on, going to minimize your potential injury. We also need to think about what it is that we're carrying in our hands. As a safety person, unfortunately, when you've been in the business for such a long time, how do you get to be proactive instead of reactive? Well, you almost have to see the worst case scenario going on while it's happening. Or right before it's happening. So that's how you don't want to be reactive. Once it's already happened, it's too late. So how do you stop it? You got to see it before it happens. So when I see somebody coming down the stairs with a canvas bag filled with the tools, I unfortunately see them falling down the stairs and see them being impaled on what it was that is in their canvas bag that they were carrying. So, I truly, like I said, how do you get to be proactive? So, I see somebody, maybe not, wanting them to not rush and wanting them to hold the handrail and pay attention and not rushing and flying down those stairs and things like that. So, always one hand on the handrail, 3 points of contact, 2 hands, 1 foot, 2 feet, 1 hand, however that works out. Always important on stairs and ladders. So best practices require all workers to use the handrails when traveling up or down the stairs. Avoid carrying objects with both hands. You need one hand available. Don't carry bulky objects that block your vision. Nothing should be protruding from the surface of the stairs. I've seen scaffold tubes. I've seen a variety of different things. People using stairs for their personal storage space. I've seen a little bit of everything on stairs. So, just be very, unfortunately, sometimes we do need to stop and take time to clean up our area, even if it's not our stuff. Unfortunately, our mom doesn't come to work with us. She ain't going to clean up after us. My mom ain't clean up after me anymore. So even if she was at work, she can tell me to do it myself. So, unfortunately, not everybody cleans up after themselves, and we're the next one to go work in that area. We're now responsible to clean that area up, because guess what? The guy that left all his stuff there, he's not the one working there anymore. He's not the one that's going to slip, trip, and hurt himself. So, we need to be mindful for ourselves and clean up our area, even if it's not our stuff. In the perfect world, everyone would clean up after themselves, right? So, sufficient lighting to eliminate any shadows for sure. Spills, wet spots, or any debris should be cleaned up immediately. So careful climbing of stairs. Take only one step at a time. Keep one hand free to grasp the handrail. Limit your load and make sure your vision is not obstructed. So ladders, they're most commonly used in all industries and are available in 2 basic designs, step and extension. The advantage of ladders are they come in various sizes. So they're often easily moved, easy to use, cheaper than using a scaffold or aerial lift platform. However, training is often overlooked as it's seen as being too simplistic. It's just a ladder, right? However, nothing could be further from the truth. Falls from ladders contribute to a large number of serious workplace injuries and death every year. The job at hand may only take a minute, but a fall from a ladder can take less than a second. Injury stats show that the use of ladders present many hazards, so injuries involving ladders frequently cause permanent disabilities. So there's some hazards that would be associated with permanent disabilities. So falls from ladders, struck by materials falling from ladders, tripping over erected or ladders lying on the floor, lifting heavy ladders, striking persons or objects when carrying ladders, and contact with electrical equipment. I've been struck by a ladder myself. I was at a job site in Red Deer, and it was the end of the day, and it had gotten a bit windy outside. Somebody had taken a ladder and they had left it up in a vertical fashion, and it was leaning against a column. And I walked past the column, and the wind came right at that time and pulled the ladder off the column, turned it sideways, and smacked it right down on the back of my head. I was certainly appreciative of my hard hat that day. I think I actually took it home, polished it up, slept beside it. I was really appreciative of it. So when I said in the last module or in the last webinar, you know, PP is our last line of defense. We don't ever want to have to rely on it, but we're sure glad when it's there. And let me tell you, I was sure glad that day when my hard hat was there. I didn't put that ladder up there. I didn't know that ladder was up there. All I know is the next thing there was a ladder hitting me in the back of the head. So definitely there could be some permanent disability associated. I had some neck injuries and some things like that. So when you're using ladders, stand on a ladder instead of a chair, table, bucket, or box. Use the correct ladder for the job. Never step on the top platform of any ladder, including a step ladder. So choosing the right ladder. So that's the big thing. There's so many different types of ladders out there. Some people just think, hey, I just need to extend my reach. I need to get up higher. They don't think about the type of ladder that they're selecting. And sometimes the sourcing or procurement person that purchased the ladders, he doesn't know the difference either. So sometimes that guy is just purchasing whatever's the cheapest, whatever he can get his hands on. And it may not be the right class. It may not be the right type for the job. So selecting the proper, so there's a few different steps in selecting the proper ladder. So first, we're going to select the proper ladder style. So choosing the right style for the job. So various ladder types are designed to keep you safe and to keep you safe and productive when climbing or standing. Using the wrong kind or simply ignoring the limitations of climbing equipment can result in a fall or serious injury. So many users only know the basic step and extension ladder. So we're actually going to briefly talk about 5 different types of ladders today. So we've got extension and straight. We're going to talk about fixed access. We're going to talk about step ladders, trestle ladders, and tripod orchard ladder. I'm just going to mute myself here and turn on a little video. So this is from WorkSafe BC. I think Matt is also going to share some of the links to the videos and things. There's a couple, 2 little videos in this webinar. So we're going to play the videos, but also Matt's going to share those links with you.
Residential home construction. It's all about time or not enough of it. And money, making every penny count. But maybe it's time to start thinking about something else.
Hey, Lucky. Yeah? I need you to get the nail gun off the roof.
All right, no probs.
You know what you're doing with the ladder, right?
Yeah.
And get the big ladder.
How many mothers do I need?
He was such a know-it-all. You could never tell him anything. Look, I don't have time to babysit. Look, it's tough. It's tough getting people who know what they're doing. If they know what they're doing, they're working. But he was a good kid. He tried. I see his parents at temple every week. I don't know what to say. He's gone. And I have to live with that for the rest of my life.
Always place the ladder 1 foot out for every 4 up. Make sure the ladder extends 3 feet above the top and tie it off. You're a pro. There's always time to do it right.
All right. Love WorkSafe BC. They do such a great job. So extension ladders. So I think that was a really great video. It also shows us that 4-to-1 rule. In one of my classes, somebody said a 1-to-4 rule. We're not building a ramp. We actually want to go the other way. We want to go up. not out. So, extension ladder. So you might want to hang on to those numbers. I think there might just be a question on your webinar questions about that 4-to-1 rule. So you might want to hang on to that info. So extension ladders, they are 2 or more sections of straight ladder arranged so that they can fit together for more convenient storage or extend on a sliding mechanism to expand the length of the ladder. These ladders are not self-supporting and require an upper support or structure. So the maximum extension ladder with 2 sections is 49 feet, and with more than 2 sections is 66 feet. So there's a little description on the side there, and you guys are going to have access to this PowerPoint and stuff as well. So that'll be available to you. So extension ladder best practices. So always inspect the ladder before use. Use the correct class for the job. Use the 4-to-1 rule when setting up the extension ladder. Stabilize the footing and secure the top of the ladder. I can't tell you how many times I've walked up to a ladder and those feet are flipped up. You know, there's rubber feet with some grips on them. They're meant to sit on the ground. They're not meant to be flipped up. They're there for a reason. Use fall protection if required. Extend at least 3 rungs beyond the support structure for access to an upper level. Remember to maintain 3 points of contact and ensure it's locked and stable. And there's another little kind of cheater piece there, a cheater sheet there to the right, and it basically says some of the same stuff. You know, it talks about 3 points of contact. If you don't tie off the ladder, stake it to the ground. You should have someone else hold the bottom of the ladder. That's a good practice. Use ladder with non-slip feet. So there's a whole bunch of little tips and things here for extension ladder best practices. So fixed access ladders. So, you know, some of these ladder cages and things I always found very interesting. When I first when, you know, I came from BC, you know, orchards, apples, cherries, plums, peaches, you know, it's all about picking some fruit and hanging out. So I'd never seen a ladder with a ladder cage. You know, I've seen wooden ladders in the orchard. That's kind of, you know, where I grew up, and that's I didn't grow up in Alberta, and I didn't grow up seeing a lot of industrial type of things. So when I first moved to Alberta and I started to get into safety, and I went out to a refinery, and I was like, oh my gosh, what is this big ladder cage for? So I'd asked a fella that worked at the refinery, and he said, well, that ladder cage is there in case you need a break. He said, you can put your feet on the rungs, and he said, you can stretch yourself backwards and rest your back on there. Well, you know, I'm 5'5" if I lie about it, and there's no way my legs are going to stretch and be able to allow me hands free to have a rest in the middle of the ladder. So what I have found about the ladder cage is that if you're wearing a tool belt, it'll probably be sure to get some of your tools caught up. It's really, and if you happen to fall and you're in that ladder cage area, just kind of make sure the body falls straight to the bottom. Other than being kind of a bit of a mental reprieve for people, I'm not sure. And once they get to the top of the ladder, because some ladders used to be really tall. And now there's some legislation and requirements that say, you know, your ladder can only be so tall before there has to be a break or a step or a relief for the person to get to a platform, have a break. If there isn't one, there better be some type of fall protection system attached to it, a rail, a cable system. If it's a ladder that's obviously being used quite often, you want something that's a rail or a cable, something that's more substantial than a rope system or something like that. So there's certainly on permanent ladders, depending on the height, should definitely have some type of fall protection climbing, you know, assistance there for you, you know, to be able to be tied off while you're climbing. So maintain 3 points of contact. So we talked about that. 2 hands, 1 foot, 2 feet, 1 hand, whatever the case may be. Make sure you can accomplish that. So step ladder means a self-supporting portable ladder that is not adjustable in length and having a flat steps and a hinge back, and whose back section is either a single ladder or other supporting device, but does not include a step stool or a platform ladder. The maximum length for a step ladder is 20 feet. So step ladder best practices: inspect the ladder prior to use the correct class for the job. Yep, there's different classes. Ensure it's locked and stable. Don't overbalance by climbing too high. Observe the warning on the last step. Some people think that that yellow step is the last step. That's not. It's actually the step underneath it. That's the last step. So use fall protection if required and respect weight capacity limitations. That's right, there's weight capacity limitations. So we're going to talk about ANSI and CSA grades of ladders and their weight capacity requirements. A trestle ladder, lots of people probably haven't seen or use these. It means a self-supporting portable ladder, non-adjustable in length, having two sections and hinged at the top so as to be able to form equal angles with the base. So the maximum length for a trestle ladder is 16.5 feet. And then an extension trestle ladder, often used in pairs to support a scaffold plank. So kind of a multi-purpose thing. Tripod orchard ladders. I am not spending a lot of time on this. Read the bottom line. Always read the manufacturer's specifications prior to use. So the biggest thing for these is that they're actually not meant to be on a solid flat surface. So if you're trying to put this on some shiny old concrete, it's not going to go well for you probably. This is actually meant to be in dirt, on grass. You know, you can see it's got that one pole in the back. It's actually meant to be a little bit of give to that kind of ladder, just based on the size and the construction and things like that. So, you know, meant to be on some ground that's not, like I said, a solid flat or slick surface. So if you are, you know, if I'm going back home to pick some fruit, then I definitely am going to be looking at the manufacturer's specifications before I get up on that tripod orchard ladder. You know, it's got one stick in the back that's holding it up. So there's definitely a very specific application. So select the proper height. So here is a step ladder reach guide. Some people have no idea what size of ladder that they actually need for the reach that they're trying to attain. They just grab whatever they think is going to work the best and away they go. So here's an extension ladder reach guide and here's a step ladder reach guide. I'm not going to go through all of those numbers. Just know that it's available. So hopefully you print this out and stuff. Easy to find. Your old Google will look it up for you. So we'll just quickly go over a couple numbers though. Extension ladder reach guide would be ladder height of 20 feet. Your maximum reach is 19 feet. 32 feet is 31 feet. 40-foot ladder is a maximum reach of 37 feet. And then it's got the height to the gutter or top support. And then you've also got your step ladder reach guide. So with a step ladder, you know, you got a 6-foot step ladder, you've got 10 feet of reach, and 8 foot, you've got 12 foot. We'll go right down to the bottom. So for a 16-foot step ladder, you've got 20 feet of reach. So with the extension ladder reach guide, you can see that you need to consider the height to the gutter or the top of the support. So remember, you should have at least 3 rungs beyond that height of your support or your gutter. Excuse me. And we also have duty ratings. So I have provided the CSA and the ANSI duty ratings. Sometimes we're going to see things that actually are duly certified. So they'll have an ANSI and a CSA rating on them. So just because something's got a CSA rating and it's got an ANSI rating and the ANSI exceeds the CSA, it doesn't mean that it's no good. It just means that CSA doesn't have anything greater than that. So let's just go to the duty ratings chart. It's probably the easiest thing to do. So on the left is your CSA. CSA is always, you know, here's a little tip for you. 352 pounds is the new CSA rating. So that's going to be a question. Not here, but coming up in another module. So just to give you an example, you know, our harnesses for CSA, 352 pounds. And then you go over to OSHA and ANSI and they've got like 400, 420. They've got some other numbers that are always seem to be bigger and higher than ours. And it's kind of the same thing with these ladders as well. So, you know, a grade 1 for a CSA is the heaviest, and that's 250, where your type IAA special duty rating is a max of 375. So that's the difference between Canada and the US. The choice of the proper material. So there's a number of different materials. Each have their own advantages and disadvantages as well. So the different materials most commonly used would be aluminum, fiberglass, wood, and steel. for ladders. So we're going to talk about each one of those materials. So aluminum is the most common material. It's lightweight, moisture and corrosion resistant, but aluminum conducts heat and electricity. Therefore, it should not be used where either of these conditions exist. So fiberglass is an engineered or man-made material that consists of strands of high-strength glass fibers that are encapsulated in a resin mixed. Fiberglass is a non-conductor of heat and electricity and is moisture and corrosion resistance. So fiberglass ladders are heavier than aluminum ladders, but they should be used for all electrical work or where accidental contact with electrical wires may occur. So wood is a natural material and it's heavier than aluminum and fiberglass ladders. Because it's a natural material, it will have some variations in the strength. It can splint, rot, warp, and absorb moisture. This is a problem. Wood ladders are non-conductors of heat and electricity when kept clean and dry. Wood step ladders do not usually come equipped with non-slip feet and therefore should not be used in workplaces. So wood ladders must not be painted because it may hide critical flaws and cracks. They really shouldn't be used in workplaces anymore because of the fact that they are a natural material and they can splinter, rot, warp, and absorb moisture. That's another reason why you're not going to see some stuff stuck to it like the anti-slip stuff, because you don't want anything stuck to it to cover up and hinder your inspection. So steel ladders can be very heavy, but are designed to meet increased load requirements. They conduct heat and electricity. Therefore, they should not be used in these environments. As well, steel is susceptible to rust and corrosion. So ladder inspection, storage, and maintenance. I kind of left this in here, just for everybody, like I said, if you've got the information right handy when you go to print it off. So repairs should only be carried out by the manufacturer of the ladder. Ladders found to be defective should be taken out of service and they should be tagged and removed from the location, from the work area. I found that giving it to the tool crew guy, sometimes it ends up back out in the field. So sometimes I like to remove it from ever having the opportunity to make it back out into the field. So danger, do not remove, red tag it, make sure that it's inoperative. Somebody cannot accidentally go and use that. So inspection procedure. So we're going to inspect everything before use. And I'm not going to go over this part, but I'm just going to talk about hard goods in general, because hard goods actually apply to our fall protection equipment as well. So this is going to kind of be a segue into inspection. So hard goods are hard goods and soft goods are soft goods. So it's pretty simple. Hard goods are carabiners, snap hooks, D-rings, anything that is a metal component. So a ladder typically made of metal components in some way, shape, or form. There's some fiberglass on there as well. There's some fiberglass stuff, but we're basically looking for the same types of damage, right? So with metal items, we're looking for cracks, corrosion, rust, pitting, bends, dents, kinks, deformation, physical abuse, damage of any sort. And then I'm looking for, so the 5 basic things in inspection and fall protection truly could be used for almost anything. There's a few things that might not apply to certain items. So hard goods is number 1. Then we've got soft goods. Then we've got labels and tags. We need to make sure that our ladder still has its label. It still has its tags. I know what it's good for. I know what it's rated to. I know when it was, it's got the manufacturer's tag on it. So we've got hard goods, soft goods, labels and tags. Stitching. Stitching is another one. Maybe we don't have any stitching on ladders, obviously. So that one would be not applicable. And then functionality. Does it function the way it's supposed to? Do the locks on, are you able to lock up the ladder the way that you're supposed to? And all the same stuff. If you look at that, look for wear. We're looking for wear, deformation, damage, or physical abuse, right? So whether we're looking at a harness or we're looking at a lanyard, we're really, truly doing the same things. So I always say for inspection, inspect things from top to bottom and end to end. So we've included an inspection criteria for ladders and stuff for you if you're unsure of what you should be looking for. And also, don't ever negate, always number 1, first and foremost, you're looking at the manufacturer specifications for what their requirements are for inspection. There's methods of storage and maintenance. So store ladders where they're not exposed to weather, prolonged periods of UV. Ladders should be cleaned on a regular basis. Moving parts should be kept clean and lubricated. Like I said, functionality, that was number 5 on that list, right? And it doesn't have to be in that order. If something doesn't function the way that it's supposed to, I guess it's not going to make it very far through your inspection after that. So store ladders horizontally on racks. Inspect for common defects such as broken rungs, split side rails, worn or broken safety feet, oil or grease, which makes climbing surfaces slippery. I think I talked about that. Tag and defective ladders, destroy ladders that cannot be properly repaired, prohibit repairs which include tying or binding with wire, prohibiting the painting of ladders. This can hide cracks or other weak points. Okay, falls to a lower level. They account for over 13,000 accepted lost time claims in 2017. So falls to a lower level include falling through an unguarded opening in a floor, excavation, fall from a roof, etc. Material handling areas and unguarded edges are inherently dangerous. And because of that, federal and provincial territories have developed specific rules to control these types of hazards. So check with your own legislation. The most effective way to reduce the risk of falling is to eliminate the need to work at heights. If this is not possible, this is highlighted, italicized, and underlined for a reason. Okay, I'm just saying it might come up on your questions. So the 4 main ways. Matt, are you paying attention?
Always.
Yes. I'm saying, I know where some people have maybe not answered that questions correctly in the past. So I'm just trying to help out my team.
Well,
So 4 main ways to read. He's sitting forward. He's paying attention now. So 4 main ways to reduce the level of risk. They are known as controls. So each will be unique and to each work site and the work environment. So they may include. So this is now we're past hazard assessment, right? We're like we're past the hierarchy of controls. We're now in fall protection. So we've decided we're at our last line of defense. We're using fall protection. So a form of fall protection could be guardrails. This is a passive fall protection system. We don't have to do anything. It's just there to help protect us. So where fall hazards cannot be eliminated, permanent or temporary guardrails or handrails form a protective barrier. So that's going to be number 1 on your list would be guardrails. So a nice passive fall protection system like guardrails, that's a great form of fall protection. The next most preferred after that, we're going to the least preferred, right, would be fall restraint. So after eliminating fall hazards and installing guardrails, if there's still, this opportunity to have a fall restraint systems will restrain you from having the opportunity to fall. So that is, of course, far more preferable than tying ourselves off in a fashion that does give us the opportunity to fall. So we want to think about travel restrict or travel restraint, travel restrict first. And then fall arrest. So you're like, hey, I've used guardrails. That's not going to solve my problems. I've tried fall restraint. I've tried, to limit my fall distance, but now, you know what? I only have fall arrest as my only possible solution. So that's the next level. So that would be number 3 on your list. And then work procedures. So we did talk, and I don't want people to get confused here. So, the hierarchy of controls, we talked about PPE being at it's the last line of defense. But once we're in it, the least preferred method of saving someone or preventing a fall is work procedures. So last line of defense is PPE. That means we're actually have an opportunity to fall potentially. We want to try and eliminate the fall hazard altogether by doing a bunch of other stuff first. We can't do that. So now we're in our last line of defense. The least preferred method is work procedures. Work procedures are like, don't fall. Well, telling someone not to fall isn't going to be nearly as preferred or effective as having a handrail or having a restraint system. So telling someone not to fall isn't going to stop them from falling. Hopefully we've trained them and made them more aware and, but slips, trips, and falls can still happen. So there's going to be a question coming up, and I'm kind of harping on this a little bit because I want you to be successful. So our last line of defense is PPE, but our least preferred option is going to be work procedures. So those are 2 different questions that are going to be coming up. Holes and openings in excavation. So falling to a lower level, they can be bear traps waiting to be strung. waiting to be sprung. So I actually, at Syncred that I worked at, a fellow was trying to do his good duties and he was trying to do some housekeeping. He picked up a large piece of plywood that was covering a hole. It wasn't marked, it wasn't secured, it wasn't spray painted, or didn't say anywhere on it was an open hole. It was just a piece of plywood laying on the ground. He picked it up and it was a large piece of plywood, so it was covering his vision. He took 2 steps and he fell into the hole that he had just removed it from. We had another scenario where up on a structure on the grating that goes around a vessel, somebody came onto day shift from night shift, and they were walking along that graded area, and somebody had removed a piece of grating and put a piece of flyer blanket down, all nice and perfect, over top of the hole. So the worker was walking, just thought that there was just a piece of fire blanket on the ground, did not think that there was any grating missing, stepped on it, and as soon as he stepped, he started to fall, and he got himself kind of stuck sideways in the, like, the grating dug into his leg and a bunch of other stuff. So as soon as he stepped, he started to fall. So he kind of was like wedged in that hole a bit sideways. The grating beat up his legs pretty good. It did manage to stop him from falling about 30 feet down to the next level if he would have actually hit the next level and not continued straight down to the ground. Hole covers, they need to be anchored, they need to be secured, they need to be marked that they're a hole cover so that somebody knows that that's what they're for. They should have an anticipated weight rating. So if you're going to have a bunch of tools and equipment and a bunch of stuff that's going to be going, or a piece of equipment that's supposed to drive over top of it, you must have an anticipated weight rating for that cover. So these people, so this is very frustrating, this video. There's no talking in it or no audio except for me. Lucky you. So this scenario is very upsetting to me. There is not 1, not 2, but 3 coworkers that all they had to do was communicate with this lady. They made some assumptions that she knew what was going on because it was happening like within inches beside her. She was busy. She's busy doing something else. They made it so don't ever assume that your coworker knows what you're doing just because they're right there. I always say miscommunication can only be fixed with communication. And I would rather somebody tell me something that I might already know that's going to save my life than make the assumption that it is something that I know and I don't. So these people create an open hole. 1, 2 co-workers, nobody says a word to this lady. This guy puts his hand up as he squeezes by her, doesn't say a word. There's co-worker number 3, and away she goes. So this lady, from my understanding, she did pass away. So she did have some additional complications that did not allow her to recover from her injuries. Had she not had those injuries, she would probably still be here. So very unfortunate, very sad. All that would have taken was obviously a really terrible setup to start with, but somebody created an open hole. There was no communication, there was no barricade, there was no awareness made, right? They just created an open hole and that was the end of it. So hole cover, so, you know, if you're not able to do a hole cover and you're just like, you know what, I want to keep somebody away from this area altogether, maybe you should just put up a handrail. So maybe there's something, I'm not sure, you know, be interesting to know what they ended up having to do because of that situation. Maybe they have a little piece of scaffold that they now have to put around that hole when they're going to make it, create that open hole scenario so that nobody can fall in. But if you just need to avoid people being over top of that or being around it, just create a handrail and let's just stop people from having that opportunity. You'll notice excavations, quite often this orange snow fencing, it's really for visibility. You know, they should be well lit. We want to make sure it's far enough away from the edge of the excavation so there's not sloughing and we don't have our flagging and signage material, whether that's snow fencing or whatever it is, be falling over into the excavation. So it truly is just to keep people away from that area. They don't need to be there. It's just a visible warning. There's a big hole over here. You don't need to be here. Don't drive over here. Don't come over here. Unless you're in this area, then there's typically a safety person that's associated with monitoring the folks that are working inside the excavation that need to be there. So obviously, if there's any hazards in your workplace, no matter what they are, it's extremely important that you discuss them. Go chat with your manager about them, your supervisor. It's their responsibility to take some action, but it's your responsibility as a worker to report those things. It's your employer's responsibility to make sure there's something done about those things. All right, in this webinar, we talked about how long it takes to fall, types of falls, same level falls, slips and trips, stairs and ladders, types of ladders, falls to a lower level. And we talked about best practices to avoid falls as well. So participant questions, I know this is a recorded session, so you all are going to have a chance, I believe, to submit some of your questions. And what we're going to end up doing in our next webinar, in webinar number 3, is we're actually going to have a follow-up session of a bunch of questions that came out of webinar number 1. And then probably in one of the other webinars following up, maybe 4, 5, or 6, we're going to have another additional time to cut out some time for questions. So if you do have any questions along this process and you're like, this is a recorded session, I can't ask any questions, you certainly can. We want to make sure that we're answering everybody's questions. So in the next webinar, we're going to take some time to do that. So if you do have any questions about this session itself, please do send them over to our friends at Levitt. They're making sure that we get those back. So some webinar questions for yourselves that are going to be available to you when you get finished this. So how many steps are there in selecting the correct ladder? When setting up an extension ladder, what is the proper ratio or angle, the rise versus run? Remember, we're not building a ramp. How many points of contact should you have when climbing a ladder or stairs? And what are the 4 main ways to reduce the level of risk, also known as controls? So I warned you it was going to be there. So that's what I've got for this webinar. So I'm going to turn things back over to Matt, and hopefully we see you on the next one.
Perfect. Well, thank you, Jennifer. This was really interesting. A lot of new information for me, maybe for some of our audience as well. We'll find out when they submit their answers to the webinar questions. So thank you, everyone who is attending webinar number 2, and we'll see you here again for webinar number 3.
Thanks, everyone.